Hi guys, and welcome to analyzing the general form of any rational equation. So if you haven't looked at the first video that just kind of explains the general form of any rational equation, you should go back and look at that because this is a continuation from there. So just as a review, we've got these 5 conditions that will tell us just by looking at the equation of a rational function, we can tell certain things about what the graph is going to look like. Okay, so the first thing that we can tell is about the x-intercepts. So the x-intercepts of the graph, that's where y would equal 0, and so the x-intercepts are wherever the numerator equals 0. So for example, let's look at a here. The numerator is 3. 3 is never equal to 0, and so what that means is that there are actually no x-intercepts, that this graph never crosses the x-axis. Okay, so if we were asked what the x-intercept is of A, we would say that there is none. There's no x-intercept, so none. Okay, so now let's look at B. So B here, the numerator is negative 5x. Okay, so if we set that equal to 0, so if you know that negative 5x equals 0, then x, if we would just solve for x, and the way that we solve for x would be by dividing both sides by negative 5, and you end up with x equals 0. So that tells us that there's a point on this graph, actually at the origin, at 0, 0, because at the x-intercept, y equals 0, and we just found that x equaled 0, and so we would know that on this graph there would be the point 0, 0 there. So when you're writing your x-intercept, you always want to write it as an actual point. So that's the 0 that we got from the x there, and then the y-coordinate of your x-intercept will always be 0. Okay, alright, so now let's move on to the next bit here. Let's move on to the vertical asymptotes. So for vertical asymptotes, this can be the same for every graph. It's where the denominator equals 0. So sometimes you'll have only 1, but other times you'll have 2, and sometimes you'll have none. So let's look at the first equation again. So the first equation, we would have x squared plus 2, so that's our denominator. So x squared plus 2 equals 0. Sorry, yep, x squared plus 2 equals 0. And so in order for that to be true, we would have to have x squared equal to negative 2 in order to get 0. Except you can't have x squared equal to negative 2. That's not allowed. X squared can't be negative 2 because then it would have to be an imaginary number, because no number squared can equal a negative number. So that means that actually, again, we're going to have no vertical asymptote. So we can say there's none, no vertical asymptote. Okay, and now let's look at our example over here. So over here, our denominator is x squared minus 9. Okay, so we're going to set that equal to 0. So x squared minus 9 equals 0. We would then add 9 to both sides. And so you end up with x squared equals positive 9. And so that we can do. Okay, so we could take the square root of both sides, and you end up with x is both, you got 2, x is both positive 3, because positive 3 squared gives you 9, and negative 3, because negative 3 squared also gives you 9. So that means that there's going to be 2 vertical asymptotes, one at x equals 3 and one at x equals negative 3. And we'll look later at how you would go ahead and graph those. Okay, and then the final thing that we're going to look at is the horizontal asymptote. Now, for both of these examples, it's the same. We're going to use the same rule. We're going to use rule number 3 here, where m is less than n. Remember that these are the exponents. So m is the exponent on top, and n is the exponent on bottom, the largest one. So on A, we have no exponent on top. Okay, so the one on the bottom is obviously larger. And then here for B, you have x to the first power on top, and then x squared on the bottom, with is larger. Okay, and then so that just means that for both of these, since m is less than n, y equals 0 is going to be the horizontal asymptote. And you don't have to do anything special with it. You just say that y equals 0 is the horizontal asymptote. There's no calculations that you have to do when you have that m is less than n. And that's it.